Hi everyone, and in this podcast we're going to take a look at air masses and fronts. To start with, we need to give a definition to air masses, which is going to be a huge body of air that has similar temperatures, humidities, and air pressures. So now that we know the definitions, we have to be aware that there's specific types of air masses. One of the types of air masses is called a continental polar. Another one is called the continental tropical, another one is called maritime polar, and another one is called the maritime tropical. And what's going to happen is that you're going to start to see that these different names have specific meanings. So for example, continental is usually formed over a dry part of the land, and so continental means it's going to be dry. The word polar means that it is going to be cold. And so if we combine these two together, it means that it is going to be a dry and cold area. Okay, so the air mass, or that huge body of air, is going to be dry and it's going to be cold. Another one is the continental tropical. So again, we take that continental word and we say that it is going to be dry. And we use the word tropical to tell us that it is going to be warm. So now we have a dry, warm set of air. Maritime, which means wet, and so polar is going to again mean cold. So now we have wet and cold type of characteristics. Maritime tropical, again, maritime means wet, tropical means warm, so it's going to be wet and it is going to be warm. And so what we start to see is that these types of air masses form in specific regions. And some of the places where they form for the continental polar is usually going to be in central Canada or in the northern part of the United States. The continental tropical is going to be somewhere in the southwest US or near Mexico. The maritime polar is going to be in the North Atlantic or the Pacific Ocean. And the maritime tropical is going to be down near the Gulf of Mexico or tropical Atlantic areas or even the Pacific Ocean. And so if we take this and we now apply it to the map of the United States, you'll see that this air mass is going to be found in different regions. So here is that continental Arctic area where, again, we're using the word continental, meaning that it is going to be dry. And this time we used Arctic, which is very, very cold. Sometimes when we have negative temperatures, this one will drop down from Canada to give us very cold temperatures. And we'll actually experience one of these later in the week. But again, here's our word continental and polar, which means that it's going to be dry and cold. Over on both coasts, you see that there's the tag word maritime, which means wet, polar, which means cold. Down here we have maritime tropical, maritime being wet, tropical being warm, so wet and warm. And we have continental polar, continental tropical, which is going to be dry and warm. And then here you see there's a maritime tropical, which is going to again be wet and warm. And so you can start to think about how these affect us in the winter months. We definitely see these two types, continental polar and continental Arctic, that come into our area. A lot of times we have cold and wet. When we get our snowstorms, they come from different parts of the west, and sometimes they'll come up from the south as well. But when it starts to get to be spring and summertime, we start to see these types of air masses that move into our area where we have very, very dry, warm conditions, or we start to see that it's warm and wet, so we get a lot of our storms from this. And so air masses move based on the prevailing westerlies, which we learned about in our previous chapter, and also the jet stream. And what happens is that a lot of times these air masses will collide with one another. So as they're moving along with the jet stream, they bump into one another. And as they bump into one another, we call that a front. And so it's a boundary where two air masses meet. Now there are specific types of air masses and fronts. We learned that there's the different air masses, that maritime tropical, maritime polar, there's the continental tropical, continental polar, but we also have specific types of fronts, so when two air masses run into each other. And one of those is called a cold front, and so here we have there's the direction of the front moving, so it's moving in this direction, and there's a large pocket of cold air which is going to overtake the warm air, and so the warm air is going to get forced up. And so what happens is that we start to see that there's warm, moist air that gets forced up, and a lot of times this results in clouds or rainy conditions. So a cold front is a larger air mass of cold air that's going to overtake the warm air. This over here is the symbol on a weather map for a cold front. The next one is a warm front. Again, you see that the direction is moving this way. This time now we have a large amount of warm air that's going to eventually overtake the cold air, and it kind of just covers it up and eventually will take over that region. And so the cloud development becomes warm and moist, and so usually when we see warm fronts move into the area, the temperatures begin to rise up. And this is the symbol for a warm front. There's going to be the red with the half circles. The other one was the blue for the cold front with the triangles. Another type of front is going to be a stationary front, and a stationary front is where you have basically two fronts that are equal to each other in terms of size, so the air masses are roughly the same size, and neither one is able to overtake the other one right away. Eventually one of them will win out, but until that happens, there's often a lot of cloudy days, there's a lot of precipitation, and sometimes these can take 2, 3, sometimes close to a week before they'll move through. And so when we experience a bunch of cloudy days and overcast days, a lot of times that's because a stationary front is stuck, they say, in our area. And again, all it is just the same amount of warm air and cold air bumping into each other, and neither one is able to overtake the other one. So it's almost like a wrestling match between the two of them, where the warm air is trying to overtake the cold air and the cold air is trying to overtake the warm air, but they're the same size, and so a lot of times there's just this cloud and precipitation that's associated with it. The symbol for that is going to be a mix of half circles of red with triangles of blue, which means that there's warm and cold fronts that are in the area. So we call that a stationary front, and that's the symbol. An occluded front is where you have two cold air masses with one warm air mass that is stuck in between the two of them. And so what happens is that the two cold airs are bumping into each other and forcing the warm air to rise up. And so this one again associates with clouds and rain, and so they call it occluded because of the fact that it's stuck in between the two of them. And the symbol for an occluded front is going to be kind of this pinkish purplish color where you have half circles and you have triangles, again representing that there's warm air and cold air. So those are the four different fronts: cold fronts, warm fronts, stationary fronts, and occluded fronts, and they are important in terms of what our weather brings with them. This is an example of a weather map as to what a meteorologist would use to display information to people. And so again, you can see that down in this region, there's the half. This is the blue line with the triangles, and so what we'd say is that there's a cold front that's in this area, and depending on the direction that it's moving, which you can tell that it's moving in this direction, it's going to bring cooler temperatures, clouds, and possibly storms to this region. Up here you can see that there is the red with the half circles. That represents a warm front. It is moving in the direction of this, which means that there's going to be warmer temperatures in this area. And so here you start to see that there is some reds and blues, which tells us that it's a stationary front, which means that, again, you have two types of air masses that are equal to each other, and so it's going to be stuck or stalled in this area for a longer period of time. And you see that there are these H's and these L's. What these represent is high pressure systems and low pressure systems. And we're going to talk more about this one in class, but what it really means is that if you have a low pressure system, it is going to bring oftentimes change in weather conditions. And so you're going to see cloudy days, rainy days. It's going to produce kind of unstable weather. And so the L's represent low pressures, The H's, on the other hand, are going to be where it is going to produce very stable weather. High pressure systems mean that they are going to be stable, and the weather is going to be fair. It's going to be oftentimes sunny, not a lot of clouds, and so we can interpret a lot of information just based on looking at this. We can tell that these areas are most likely going to be cloudy, or that they're going to have some type of precipitation that's associated with it. These regions here are going to have high pressure, which means that the weather is going to be stable. We can almost predict that there's going to be partly to mostly sunny skies. And then once you start to account for where the air masses are located, you can kind of predict where the L's and the H's are going to fall along this line and what type of temperatures that you're going to find. So that's a quick overview of air masses. Submit your responses so I know what you struggle to understand, and we can go over it in class. All right, talk to you later.